Now we can start, I think. Hello, welcome to today's webinar with the topic Power Plant Fan Corrosion Protection. As I can see, we have a lot of participants from all over the world. Good morning and good afternoon. My name is Ersin Çetin. I'm the regional sales manager and responsible for some regions, Germany, Benelux, and Turkey. Today, next to me is Mr. Patrick Baumgärtner. He is our product manager and our expert in corrosion protection. He will be conducting today's webinar together with me. During the webinar, you are all on mute. However, you have the possibility to enter your questions into the webinar tool. At the end of the webinar, we will be happy to answer. During the webinar, we will ask you some questions and you have the opportunity to answer from a number of possible given answers. Patrick, you can introduce yourself.
Yeah, thank you, Ersin. Welcome also from my side. Just a few words to my background. I am a former R&D engineer at TLT and developed over the last decade solutions regarding corrosion and wear issues. A very important topic regarding sustainability of processes and also for the energy transition, as we will see in this presentation. Today, I am part of the product management team responsible for service products and and also power fans. So I have two roles today, as I mentioned, the expert regarding corrosion protection and wear protection, and also now the product manager.
Okay, thank you, Patrick. Now today's agenda, we will start with the introduction and with the setup of TLT-Turbo GmbH. Then Patrick will explain the basics of the dew point corrosion. What is dew point corrosion? Which fundamentals and problems can cause dew point corrosion? We will go deeper into the theoretical explanation. And after that, we selected one case study from for you for several cases, and we would like to explain this. Here we want to address the problem on the ground and how we have solved them. Then we will show you our typical approved solutions for corrosion protection. We have several approaches here, and we want to show some approaches. Last but not least, in the end, we will have enough time to answer your questions together with our expert Patrick. Yes, TLT is a global company with many entities and branch offices in all over the world. This way, you have direct contact in your region. We have manufacturing and service locations in Germany, in US, South Africa, India, and China. We also have branch offices in South America, Korea, and Australia. If you do not have a TLT location in your region, please visit our website tlt-turbo.com to find one of our many representatives and service partners responsible for your region. Yeah, power plant fan corrosion. The energy transition poses many challenges for us and also for you. Rapidly expanding new renewable energies and others require higher flexibility than conventional plants. These are big challenges we have to overcome together with you. For this reason, the typical operating modes of the general system and also of the fans change. The number of the starts and stops of the plant are increasing. This leads to fearful of load towers, and this leads to increasing of partial load operation, lower exhaust gas temperature due to residual heat insulations, smaller gap to acid dew point lower. These all factors or challenges cause an increased load on the system, which carries risk of corrosion during operation. This risk can lead to a failure of the system, of the fan, and to the entire system. We, TLT-Turbo, offer you a tailor-made solution for your plant to meet these challenges. And now Patrick will explain the basis of the dew point corrosion. Yeah, thank you, Patrick.
Thank you, Ersin. Yeah, for this brief overview. I appreciate to share some information today with you regarding issues and possible solutions regarding dew point corrosion. But first, we have to start with some basics. Yeah, okay. As you all know, you know that the combustion of fossil fuels comes with some things to take care about with. Oil and coal contains not only carbon but also sulfur. Among other products during the combustion, CO2 and carbon monoxide is produced, and also SO2 is formed. Together with water and oxygen, the SO2 can form a strong acid, the sulfuric acid, as we will see in the next slide. And this sulfuric acid is very corrosive against organic materials and also steels, structural steels, and in some cases also stainless steels. Sulfuric acid is formed during and after the combustion due to the SO2. With the reaction with additional oxygen, SO3 is formed, sulfur trioxide. And since SO3 is a highly reactive molecule, it reacts immediately with water vapor and forms a vaporous sulfuric acid. Not a big problem yet until it's vaporous. So, but we will see when the problem gets involved. We will see this also in our case study soon. As water can form dew and fog during the day and night shift, this can also happen with sulfuric acid and flue gas. The dew point temperature of sulfuric acid is mainly depending on SO3 and water content, as shown in the diagram on the left side. Typical dew point temperatures can range from 110 degrees Celsius by low moisture and sulfur coal, for example, and up to 170 degrees Celsius by high sulfur moisture containing heavy fuel oil on the other side. The main message of this diagram tells us the higher the SO3 and the water content, the higher the dew point in a flue gas will be. And the higher the dew point in flue gas is, the more sulfuric acid is available in flue gas. If the operation of a fan is close to the dew point, fluctuations of temperature can easily cause the dew point to be undertaken, and if this happens, liquid acid will condensate as fog or film on a component's surface and cause sometimes severe damages. Dew point corrosion may lead also to catastrophic damages if one doesn't take care about it. And Ersin, would you just tell us the first question?
Okay, thank you, Patrick. The first questions which you to answer is, do you have experience with dew point corrosion on your components? So you have the possibility to choose one of the given answer options.
Okay. 35%, yes, and almost 50% now in experience.
Yo, thank you very much. We can see the most of you have experiences with dew point corrosion, and you have the opportunity to contact us after the webinar directly. We will show also our contact data. Yeah, thank you very much. And so we can go further with our case study. After presenting the basics, we would like to share one case study with you. Here are some photos for typical spots, for typical corrosions on spots on the fan Typical places are as seen here in the pictures, at the blade root, in the impeller shot, or even at the complete impeller. Of course, we have to see how far the corrosion has progressed. Sometimes we can rework small spots or replace a complete impeller shot. Maybe they may even look very familiar to you. Yes, we come to our case study. Here, I would like to present a case study for a deepened corrosion and low temperature corrosion. It is a coal-fired power plant in Central Europe. It is very close to a sea. And here are installed our fan type, fan type ID fan SEF 4220-2. 42 stands for the outer diameter of the impeller, 20 for the inner diameter, and 2 stands for stage of the fan. So in this case, we have a 2-stage fan. So the mass flow is 918 cubic meter per second. The pressure rise is 8,600 Pascal. Flue gas temperature is 140 up to 157 degrees. The dew point is 125 up to 135 degrees. So position of the ID fan is behind the Denox A filter and pre-FGD. So here you can see the exact location of the ID fan where is it installed. So Patrick will go deeper in this case study.
Yeah, thank you, Esan, for the introduction, introductory words into the case study. I will go now into some more details. So here you can see a 3D model of the installed ID fan in this special power plant. And I prepared a cross-section of this fan, as explained, which is showing some more details regarding the design. So let's have a closer look to it, and I will explain some details of the main components. So let's start at the suction box. It's aerodynamically optimized entrance for the flue gas into the fan. Then the nose fairing, which is also aerodynamically shaped to increase the efficiency of the fan and minimize pressure losses. Then the impeller blades and the guide vanes, they are formed they form among other major components the characteristics of the TLT fans and their performance. Then we have the intermediate shaft, which connects the fan to the engine. It must be protected from flue gas, and this is done by the shaft tunnel. The main bearing enables low friction, rotation, and pickup of loads during the operation. Also, it has set up the vibration measurements and a lot of other important features that are located there. Then we have the hydraulic blade adjustment unit, which performs the adjustment of the fan blade during the operation and enables high performance and efficient fan characteristics. So now after the explanations of these components, you see that they are critical parts, and it must be taken care that we protect them against flue gas and high temperatures. This is done by a standard sealing and cooling air system, and to minimize sealing air leakage into the ductwork, we use specially designed sealings. Yeah, but enough about that fan design. Let's go into the case study, into the praxis. Yeah, so here you can see the last things I had to talk about, the sealing air system, which is also at the intermediate shaft tunnel and also in the hub, the inner of the hub. Yeah, let's start in the suction box. In our case, we find only some dust and a little rust. That is absolutely normal for structural steel in an ID fan ductwork. So in the suction box, we didn't find severe dew point corrosion. This is a good sign for proper isolation and operation above the dew point. If there would be moisture, acid, liquids, or corrosion, this would be a strong indicator for missing isolation, a very close operation to the dew point, or even operation below the dew point. The pH value of these liquids, which can be found in very heavy cases, can range from pH 1 to 3, sometimes even below 1, but typically in this range 1 to 3. Yeah. Good, okay, but in this case, here in the power plant in Central Europe near the sea, we didn't find dew point corrosion in the suction box. The next part is the nose fairing and the intermediate shaft tunnel. A critical area is the connection between the intermediate shaft tunnel and the nose fairing, because there we may have turbulences in flow, no rigid connection, and due to design, rigid connection due to design. Due to the design. If the dew point is close or below the flue gas temperature, one might get condensation here at first. Fast changes in operation points significantly higher the risk. You can see the white and yellow salts on the surface here, which is iron sulfate. That's a reaction, a product from the reaction with sulfuric acid, which is condensing, and the iron of the structural steel. These salts are extremely corrosive if they get in touch with water, also during maintenance periods. This is why one should take care of that when one sees salts like that, because if you have a longer maintenance period and the moisture in the ID fan gets over a certain level, you get corrosion during the maintenance period, and this could cause even some severe damages during a few months. But here we did find severe signs of dew point condensation and starting corrosion in future, and this is why one should optimize probably the isolation or preheat at these locations, so that further condensation of sulfuric acid will not occur. Yeah, then some critical parts, the fan blades. On this slide, you can see them. I took this picture standing in the suction box, the fan blades have generally a big surface in comparison to their mass, and are heated up really quickly. So they have normally high surface temperatures nearby the flue gas temperature, and that is the reason why blades itself doesn't corrode that much normally. The critical area could be the blade foot. There it is connected to the hub and the mechanical inner parts of the impeller. With quickly changing operating points, it takes more time for these heavy components to adjust to the flue gas temperature, and so dew point shortfalls can occur. If blades are affected, it might be a sign for very close or even below dew point operation. This can lead to serious caking and balancing issues with the risk of fatal failures. In this case, we generally use cast iron blades. We didn't have dew point corrosion on the blades at all, which is a good sign for this application here. So let's go to the impeller. On the left side, you can see the impeller without blades in our workshop. One can see the red standard coating, which is only a corrosion protection for transportation. The high temperatures of operation burns this painting in a short period of time. But this is normally no problem because ID fans in former times had operation conditions with high temperature, low moisture, and a big gap between dew point and flue gas temperature. So there was no corrosion. It was not that aggressive corrosion to it. But due to the challenges we did explain in the former slides as well, it could be that we get dew point corrosion at the impellers. And so it was in this case study, due to the closed dew point operation and the fluctuation in temperature and the operation points, we did get dew point corrosion with a material loss of between 4 and 5 millimeters each year of structural steel. And this is caused by the again by the fluctuation of the operation points and the change in temperatures. Again, here you can see the yellow and white soils on the right picture. That are a very good indicator for dew point corrosion and corrosion with sulfuric acid with iron. To protect an impeller, we have certain possibilities. These I will explain later on. But here we had, in this case study, severe corrosion at the impeller shell. So the guide vanes, housing, and division flange are part of the steel work and the steel construction of our design. And as you know, because I showed it on the introducing slide, the inner of the hub must be cooled and sealed against influx of flue gas. This is important for the safe operation of the main bearing and also the hydraulic blade adjustment. The housing parts are therefore isolated with mineral wool to increase the surface temperature on flue gas side. So this you will see in this schematical image. On the left side you have the inside of the hub, and on the right side the outside with the flue gas contact. And again, if a power plant is operating close to the dew point with quickly and often changing operating points, you have a higher risk for this dew point corrosion. On the right side, on this image, you can see the surface, which is marked blue in this middle diagram, image, and you can see the housing division flange, and on the left side the impeller. So you have the gap between impeller and the housing division flange. If we plot a temperature curve over the thickness of the isolation, we get a curve like that is shown like here, which starts at the inner with a temperature of, for example, 60 degrees Celsius, which is needed for the cooling of the main bearing and the hydraulic blade adjustment unit. And then we get a temperature rise until the surface. And if the operation is very close to the dew point and quickly changing, there is no the temperature on the surface is not the flue gas temperature, but below. So if the surface temperature is below the dew point, you get condensation of sulfuric acid, and this is the reason at this location why we had here some dew point corrosion detected. It's not severe, it's only a bit, but it could cause some damages at steelwork. Yeah, and if this condensation and corrosion with sulfuric acid goes on and for a longer time, this causes, for example, caking in the between the impeller and the steelwork, and this could sometimes affect the rotor by seizing it, and during a standstill period, that you get trouble in running up the fan again after maintenance period. So second question. Second question is, on which of your components do you observe dew point corrosion the most? Just give us 1 minute. Okay, thank you. Almost more than 50% did choose the impeller and blades. Okay, thank you for the answer. If you have some questions, you can contact us, and we will after the webinar we can discuss about that. Yeah, okay, then I will continue with typical approved solutions out of the last years. After this unpleasant part, I think it's good when we show some solutions. Yeah, I will start quickly. There are typically two ways to protect fans against dew point corrosion. The first way is avoiding condensation of sulfuric acid and its corrosive behavior. The second is using of chemically more resistant materials at relevant fan parts. But attention, if we should maintain focus on the first way, because there is no if there is no electrolyte, no sulfuric acid, there will be no corrosion at all. And in the next slides, I will show you some approved measures TLT has applied in the last years to the satisfaction of our customers. So we can do that also both as new construction and we did it also as upgrades for existing fans. Yeah, isolation and sealing measures are one big measure that helps a lot. It can be done by additional isolation, sealings. We can integrate them in fans depending on the special needs. It's a passive measure that needs no additional energy, and for example, it could be silicon plates, additional shells, compensators for sealing, and all these measures lead to higher surface temperatures and then, of course, less dew point corrosion. Our second measure type is the heating. There we have three different options in generally. At first, we have the integrated overall heating, which is integrated in the TLT sealing air system and reduces the environmental impact. So low temperatures during winter or whatever, so that there are less fluctuations in sealing air temperature. And that means that you will have almost all over the year, 365 days a year summertime. And so, yeah, you can turn off the weather. If you have only corrosion issues at special locations, you can use the separated hot seal air. this is has the advantage that you have you can reduce the influence of low environmental air temperatures, and also get a maximum of cooling of critical parts, because it's not directly integrated into the sealing air system, but it's an additional one, a separate hot seal air with an additional fan and an additional heater. And the last one is the direct impeller heating. It is highly efficient and located at the most critical position. There are no thermal losses in heat transportation because it's directly located in front of the impeller, so it's the efficient way to heat critical components. And all of these heating solutions can be customized and are available in a wide power range. For example, we did apply heating systems up to 90 kilowatts heating power in the past years. Okay, one additional measure is the coating. There are coatings that could be nickel-based coatings in combination. Also, we can use thermally sprayed coatings, which can protect against wear and also corrosion with some, for example, tungsten carbide in it. Then also we have polymeric coatings which can be used. Here also fluoropolymers, flake coatings, and yeah, depending on your special operation conditions, we can use the fitting coating for that. So last but not least, as we did learn now, sulfuric acid is a very corrosive acid that is sometimes more corrosive against stainless steel as against structural steel. This is why we offer you a corrosion risk assessment based on a plant inspection to select the right materials for your application. It might be necessary to go on site and take also some samples of cakings that appear in your operation and in your plant. During a plant inspection, we can support you also with a dew point measurement to get the exact operation conditions. And together with these information, our experts and engineers, local institutes, and also our own lab, we can select the right materials like cotton, stainless steel, or nickel-based alloys suiting for your application. After completion of the corrosion risk assessment, you will get an offer for a customized corrosion protection package for your fan, including all selected measures. And in our case study, after the corrosion risk assessment, our customer decided, because of these critical dew point corrosion locations, which were the nose fairing and the shaft tunnel, and also the impeller of the first stage, he decided to go further in cooperation with us with a separated hot sealing air system and the thermally sprayed coating, which is really corrosion resistant. And now after several years of operation, we still work together and are happy that we took that step to improve the availability and also the sustainability of the fan under these heavy corrosion conditions. Thanks very much. Ersin will continue.
Yes.
Thank you.
Patrick, thank you very much. It was a very interesting contribution, and I hope that the participants, you see it the same way. We, the TLT-Turbo, perform corrosion assessment during the design and the manufacturing of new fans. Of course, we can also perform this evaluation when retrofitting your existing equipment during a planned shutdown. This is possible for TLT as well as for fans of third party. So it means for other manufacturers. Feel free to contact your service representative or the TLT-Turbo service department for more information on conducting a tailored risk assessment at your facility. We are pleased to offer you a customer solution. So it's now time for questions and answers. From the system, I can see a lot of questions. I will select some of the questions to answer it. The first question is, for the processing of the corrosion pulse, it is possible to make on site or in the workshop? Good questions. It depends on where and how far the corrosion is. Basically, we always recommend sending the impeller to our workshop to Bad Hersfeld in Germany. It's very close to Kassel for a detailed inspection. We have all the possibilities for detailed examination in our workshop. After the appraisal, we then contact the client to discuss the measures to be taken. The second question is for our expert. Has there been a major damage because of deep point corrosion in the past?
Yeah, that's a good question. Of course, there have been some major damages. For example, I explained a little bit also where, during the case study. There have been damages on blades. They have been broken, and with all problems that coming with that, I think I don't have to explain that to you. Also we have some issues with, we had some, our customers had some problems with the caking, and that they could not run up the fan again. And minor issues like holes in casings and holes in the steelwork of the duct work, and flue gas entrance in the inner part of the hub, or even flue gas exit into the environment. This can all happen if one doesn't take care of the dew point corrosion.
Okay, thank you. I can see from the system there are a lot of questions coming in. Thank you very much for that. But due to time, we are not able to answer all the questions here. But we will contact you in personal calls or meetings to answer all your questions personally. So, Patrick?
Yeah, last words. For further webinars and content, visit just our homepage or connect with us via LinkedIn. You can, and also there you will find today's webinar. It will available there. It will be available there soon. You even have the possibility to go directly to the media center on our website by scanning the QR code on the right side. Here you will find some additional webinars like wear and corrosion protection, remote service support, which is really important in this actual times, and also some basics regarding aerodynamics, and I can also give some spoilers. We are preparing now a webinar regarding AeroConsult, how TLT can support to get the most out of your ductwork and improve the fan operation. Also in terms of upgrades and change in combustion method. yeah, but you will see that in the future. So thank you very much for joining us today. And I think after the webinar, we will have some questions to you, and we would like to introduce you, invite you that you answer them, and then we can contact you after the webinar. Thank you.
Yes, also thank you for from my side, and also for your spoiler, Patrick, for the next webinars. Now you can see our contact data. You contact us directly for your problems, for your request, everything else. So feel free to contact us, and thank you very much for your participation. Thank you. Bye.